In today's video, we will be doing part 1.2 in the chapter 1 number systems of class 9 CBSE mathematics. This part 1.2 is called irrational numbers, and in today's video we'll be discussing irrational numbers and also we'll be learning how to plot irrational numbers on the number line or how to show an irrational number on the number line. From 1.1, our introduction to the number line and the number system, we know that real numbers combine rational numbers and irrational numbers. And we also know that every point on the number line represents a unique real number. So it can be a fraction, it can be a natural number, whole number or integer, but any point on the number line is going to represent a unique real number. Now, let's start with understanding how we can locate an irrational number such as root 2 on the number line. We are going to use Pythagoras theorem for this by considering a square. So if we consider a square such as this one here with sides or with these points as O, A, B and C, if you see the triangle OAB here, if OA and AB were to measure 1 unit and 1 unit, according to the Pythagoras theorem, the diagonal, the hypotenuse, that is OB, should be equal to under root OA square plus AB square. So which is 1 square plus 1 square, which will give the value of OB as root 2. Now how do we find the value of root 2 on the number line? So the next step is to transfer this square over here onto our number line. So as you can see here, I have transferred this particular square over to this number line, coinciding the point O with 0 on the number line and point A with 1 on the number line. And we have the rest of the number line as we can see here. So the process to find the value of root 2 on the number line is that once we have transferred this, we take a compass and then we take the center as O over here and we take the radius as OP over here and we draw an arc. If I can say the point that the arc coincides on the number line is P, that should give me the value of root 2. That is the process of how you can represent the irrational numbers on our number line. So this method can be used for any irrational number. Now after locating root 2, let us see how to locate root 3 on the number line. So for this, we start with where we ended root 2. So we start with the root 2 on the number line. So we have started, we have the triangle OAB here and we know this is 1 square plus 1 square under root, which is square root of 2. Now we have located the value of square root of 2. Now what I'm going to do here is, in order to find the value of root 3, we can draw another right angle triangle with one of its sides as root 2 and the other as 1. What's going to happen then? When we use the Pythagoras theorem, I can say for this new triangle and the new hypotenuse that I build, which looks like this. So this new triangle that I'm going to build with one side as root 2 and let's say the other side will be 1 here. So at 90 degrees. So this is another right angle triangle. So this side will be 1 and then that's going to be my hypotenuse. So this hypotenuse according to our Pythagoras theorem here is going to be root 2 square plus 1 square under root, which is square root of 3. So we get the value of square root of 3 and then in order to locate the square root of 3, we do the same thing as we did before. Before we do that, let's just mark this as point D for convenience and now put your compass with the center on O and our new radius for our arc is D. So now carefully we draw a new arc which is going to coincide our number line on point Q. So this point Q will be giving us the value of root 3. So what did we do? We took the center as O and radius as OD, and then we drew an arc which will give us the value of root 3. So in order to find root 3, we have started with root 2 and then we repeated the process. So in this way, again you can find the value of irrational numbers on the number line. Let's look at the exercise questions from exercise 1.2 in our textbook. So the first question has some true or false questions such as this one. Every irrational number is a real number. Is this true or not? How do we know? So in order to answer these kind of true or false questions, like we did in our last video, we are going to rely on our Venn diagram that gives us a representation of all numbers. So we know that both rational as well as irrational numbers here are real numbers. So we can agree that every irrational number is a real number. So the answer for this would be true. Now the second question says every point on the number line is in the form of under root m, where m is a natural number. So this point is arguing that every point on the number line is in the form of under root m, where m is a natural number. Is this correct? So from this diagram we can see that on the number line we can also have numbers such as -3 or minus root 6. Now these numbers are not in the form of under root m, and m is not a natural number. For example, -3 is not a natural number. So because it's an integer, so this one would be false. Third one is saying every real number is an irrational number. Now this cannot be true because real numbers can be either rational or irrational. So this one would be false. Moving on to the second question, they're asking us if the square roots of all positive integers are irrational. If no, give an example. So we know positive integers, and positive integers for example are 1, 2, 3, 4, 5, so on. So is every square root of a positive integer irrational? Let's see. Root 2, yes, it is irrational. Root 3 is also irrational. What about root 4? It is 2. So 2 is a natural number and it is not irrational. So this would be wrong. So we say no. Not all square roots of positive integers are irrational. For example, root 4 is a natural number. The third question here asks us to represent root 5 on the number line. If you remember earlier, in order to represent root 3 on the number line, I started with root 2, right? So the technique is in order to locate root n, we need to locate root n minus 1 first. So what is root n minus 1 in this case? And if we say n equals to 5, then root n minus 1 will be root 5 minus 1, which is root 4, which equals to 2. So in order to represent root 5, we need to first start with 2 on the number line. So let's draw a number line and locate 2 first. Once we have located 2, the next step is to draw a right angle triangle. So if this value is 2, in order to find the hypotenuse, which is root 5, this should be 1 unit. So according to Pythagoras theorem, we can say, for example, if this is OAB, as we have seen earlier, OB will be equal to root 2 square plus 1 square, which will give us root 5, right? So that is how I've written the value of OB as root 5. Now let's construct this triangle on our number line starting at 2. So let's say that this is around 1 unit, and if I'm going to draw my right angle triangle over here, so this is O, let's say 2 is A and this is B, so that would be 2 units, this would be 1 unit, and that would be root 5 units. Now as we remember the method before, We take a compass, we take the center as O, and we take the radius as OB, and then we cut an arc on the number line like this. Now the point at which this coincides, we can say the point as P, and now this point P will be giving you the value of root 5. That's how you can represent root 5 on the number line. That's the end of exercise 1.2.